Okay, just for a bit of a recap then on our hypothesis testing work. So, a hypothesis test as well for a binomial or, well, for a probability or a proportion is what we call it, which is a binomial, is basically where it's widely believed that a certain proportion is true, so 80% of seeds germinate in compost, or 50% of people use fairy liquid, or the chances of guessing an answer correctly out of 4 is 25%. And then some sort of claim comes, so someone basically says, right, no, I think it's less than 50% of people use fairy liquid, or I think my compost is better than that compost, or I think the student was cheating, for example. And that's then when you've got to do a hypothesis test. What you would do is you would set up your null and alternative hypothesis. So your null hypothesis is, right, we're going to assume that this is just the standard stuff, and then the alternative is either, like I said, whatever the claim is it that it's less or more or just different from. Sorry, just having a sip of my Lapsang Souchong tea. You should try it if you like smoky stuff. Try it, it's quite nice. Anyway, so what we're going to look at now then, in addition to our hypothesis testing, so after that what we would have done is we would have worked out the probability of our sample happening. So we'd look at a sample, is that more extreme than my expected value under the usual conditions, under H0, under the null hypothesis. Is it more extreme? Yes. Okay, how extreme is it? How likely is my sample to happen? Is it really unlikely to happen? If so, well, probably then H0 isn't quite true. So let's just have a bit of a recap back to our first example from that video, where the student takes a multiple choice test. There were 20 questions, 4 possible answers, 1 of them was correct. And apparently they were guessing. They guessed, in inverted commas, 10 correct. And then someone's like, nah, I think they were cheating. So in that scenario then, we had a look at our hypotheses. We said, all right, I'm going to assume innocent until proven guilty. H0, null hypothesis, he was guessing. He, blatantly a boy. H1, our alternative then is, okay, people are saying that may have cheated. Well, if he cheated, obviously then the likelihood of him getting an answer correct was more than 0.25. And then a significance level of 5% there. Now remember, your significance level is the probability where you start saying, oh yeah, this is too unlikely now. This is too unlikely to happen. This probability is too low. Something's amiss here. So we then counted the number of answers that he got correct. So he got 10 answers correct out of the 20. So that's our sample there. X is called our test statistic. N is 20, that's the number of questions. So if he was guessing here, then the probability would be 0.25. We always assume H0 is true, so the probability of H0 always goes in there. And then we see, right, so we would expect that my expected value of X would be a quarter of 20, which is 5. I would expect someone who's guessing, on average, to get 5 answers correct. Doesn't mean that they're always going to get 5, as we know. They may get a few more, they may get 6 or 7, they may get 3 or 4, they may get 10, right? Maybe? Okay, yeah, maybe. I don't know. How likely is it actually to get 10 right if you're guessing? What are the odds on that? I don't know. Let's work it out. Well, that's got my p-value. Also, I mean, if I'm checking if someone's cheating here, if someone gets 10 right and it works out that's too unlikely, so I'm saying, yeah, they're probably cheating. What if they got 11 or 12 right? I'm going to say, yeah, they're probably even more likely to be cheating. So I'm going to work out the probability then again in 10 or even more than 10 right. And that was 1 minus the probability of X being less than or equal to 9. So in my tables, on my calculator, I put X is 9. P was 0.25 and N was 20. 1 minus that came out as 0.0139, which was unlikely. It's like a 1% chance of that happening. And more importantly, it was less than my significance level. So I said, yeah, that's too unlikely in my books, because I say unlikely is 5%. So 1% is even more unlikely. So then I would have said, okay, I'm not 100% sure, but I've got strong evidence to suggest then that they weren't guessing, because that likelihood is too small. That's too unlikely to happen if you were just guessing. So strong evidence to suggest rejecting H naught. Therefore, I would conclude that probably the student wasn't guessing and that they were cheating. But I don't know for sure. But that's fairly strong evidence there that they were. So let's have a look at a bit of a different question now. So instead of having to do that every time, what about in years to come? If this happens again, have I got to do this every time I think someone's cheating? Why can't I just think of a cut-off point? Where is my cut-off point? How many questions would we allow to be guessed correctly before we accuse a student of cheating? Again, as long as I'm working up my significance level of 5%. Where's my cut-off point? Is it 10? Did the student just unfortunately guess one too many for me to allow him? I don't know. Where is my cut-off point? So what I want to try and find now then is which value then, how many answers can be guessed correctly, which X value is going to lead to me rejecting H naught and saying that he's probably cheating. Well, again, so okay, guess 10 or more, I'm definitely going to say you're cheating. Right, so let's move closer to my expected value. Let's move closer to my expected value, because the probability is going to increase as I get more towards that. Let's just try 9. What if someone guessed 9 right? Well, I'd work out the probability of them getting 9 or more right, which is 1 minus the probability of X being less than or equal to 8. And that comes out as 0.041. Yes, I would still say then, I would say, oh, that's less than 5%. Cheating. Or probably cheating. There. Okay then, what about 8? What if they guessed 8 right? Or more? If they guessed 8 or more right, what would I say then? Well, the probability of that, which is 1 minus the probability of X being less than or equal to 7, comes out as 0.1019. Okay, there's about a 10% chance of that happening then. I would say, okay, yeah, fine. Not enough evidence to reject H naught. Again, I don't say I don't reject H naught, I just say I don't have enough evidence to reject H naught, because that is greater than 0.05. So that's above my significance level. So not enough evidence there to reject H naught. So actually, the first value that I would start rejecting H naught at would be 9. So if someone just guesses 9 or more now, I know in future, right, straight away I'm going to say you're probably cheating, mate. Or I would probably just say you're cheating. I wouldn't call him mate either. And so here's the important thing. Here, one I prepared it earlier. This value, so the value where I start rejecting H naught, so the first value that gives me a p-value less than my significance level, is called my critical value. The critical region then are all the values that lead to rejecting H naught. So in this case, anything 9 or above. 9 or above, I'm going to reject H naught and say you're cheating. Another thing as well that you may hear being talked about is a decision rule. Now, a decision rule is basically, in words, what gives you the critical region. So something like this: reject that a student is guessing if they get 9 or more answers correct. So if you get 9 or more correct and apparently you're guessing, I'm going to say, nah, you weren't guessing, mate. That's too unlikely. You weren't guessing. You ain't going to get 9 or more right if you're guessing. Well, you are. How much of the time? About 4% of the time. But I'd bet that you weren't guessing on that. I would say there's strong evidence for me to suggest that you weren't guessing if you get 9 or more correct. So this is basically what a critical region or critical value is. We just have a look at values that are more extreme than our expected value. In this case, 8 wasn't extreme enough, 9 was. And that first value then, that gives us a p-value less than our significance level. The first value that would lead us to rejecting H naught is the value that we call our critical value, and the critical region are all of the values, so in this case greater than or equal to 9. That would lead to rejecting H naught. Thank you very much.